everyone for joining me. I'm Sonam. So I worked as a generative AI evangelist, pretty fancy, right? But the basic work is to take research and product to market. I also worked as an AI researcher at Sama. That means I work with clinical trials, data, and with Pfizer, etc. For the past 1 year, I have been working with for this open source library called Embed Anything. Created, maintaining it. And so today we are going to talk about text search on images with quantized ColPali. Just a little bit on the journey of this library. So I started in 2024, presented at Berlin Buzzwords. Since then, we have collaborated with Elastic, given talk at Google, and then PyCoin, and Single Store, etc. So the flow of the session will be what are the challenges that occur in the simple RAG, then visual language model, contextualized late interaction models, retrieval benchmarks, because we need to discuss benchmarks as well because our model has changed, quantization, and ONX inference. Don't worry, you might feel pretty overwhelmed in the beginning, but I'll try to explain it as easy as possible, and I will be here itself. You can reach out to me anytime. Okay, so if you have been to conferences for the past 1 year, you cannot skip RAG. So RAG is everywhere, in which you retrieve context from your vector database based on query, that is retrieval, augment it with a query, and generate your answer. But what nobody is talking about is the indexing part, which is pretty much where it takes a lot of GPUs, extensive memories, etc. Okay, so what are the problems? Before going into solution, I always say, let's dig the problem first, because problems is what motivate us for the solution. So the problem is text extraction. First problem, the extraction. So you can use libraries like PyMute PDF, which is super fast, but doesn't work well with scanned PDFs. Doesn't handle tables and images well. And I have given the notebook as well, so you can access it. The other thing is you can use OCR, which is slower, but it also misaligned the text. So you can see the output of the collab file. The text are misaligned. There's spacing, erroneous spacing, and the tables are also incomprehensible. The third thing that you can use is parsing. These days, a lot of people are pushing parsing, but I think parsing, because generation can hallucinate, LLM parsing can actually hallucinate few values, and that can lead to a lot of errors. Yeah, so not very robust. And still, it can be used for tables and images, though. Okay, so the second problem after extraction that we have to deal with is chunking. What will you put the size of chunking as? Will this paragraph be enough? Will that paragraph be enough? So size of chunking also kind of affect the results a lot. And the second problem is the context is lost in the long document. So the context could be anywhere else, like in the next paragraphs or in the next pages. So a lot of manual understanding of PDF has to have. And the third is like embedding. Embedding is nothing but numerical representation of unstructured sources like PDFs, audios, and images. So what's needed? We have to get rid of extraction, parsing, chunking, and this is where ColPali comes in. And ColPali's value is that you cannot skip visual cues. What it says that a PDF is not just text. A PDF is full of images, provide visual clues through images, through tables, through layouts, etc. Right? So no text extraction, no chunking, only visual cues. So what it does, it removes the whole pipeline of finding OCR, finding layout, finding different information, and give you just the image of the PDF. So ColPali, which is contextualized late interaction, and Pali Gemma. So we will get into this two architecture as well. So ColPali uses VLMs to embed documents to a vector space while preserving the text format. This paper actually introduces two things. One is the benchmark, that is VDOR, visual document retrieval, and the other is different models. Bicyclip, ColPali is one of them. So how did we used to do benchmarking before? Benchmarking MTEB. So Isaac, I think, has given a very good talk yesterday about benchmarking embedding models, reproducibility in benchmarking models, and yeah. So MTEB basically does different tasks like re-ranking, retrieval, and clustering, and benchmark on different embedding models. You can also provide your own embedding models and see how it performs. So documents are visually rich structure. That means it not only has text, it has images, table, page layouts, or fonts, and these information are like combined together in a document. So that's why they introduced VDOR, a new trivial benchmark, where it's like the tests are done based on like which image of the document is retrieved. So what's happening? So as I told you, we do not need all this process of extraction, chunking, pooling, etc. And we are replacing all those processes with a visual encoder, a large language model, and a linear projection. Why? We will see in some time. So all this PDF was given as an input. Now the images of PDFs is given as an input. And these generate tokens. And then LLM generate query tokens. And then this whole part of calculating the score is the late interaction mechanism, which we get into in some time. Right? So now the only inputs are the images of the PDF and the query. And these are given to, these tokens exist in 128 dimensions. Now the architecture. The architecture of ColPali has three main parts. The vision language model, that is visual representation. Late interaction, interaction happens after encoding, and contrastive loss. If you just want to visualize it from a few heights, it's like a visual encoder plus projection layer, and then late interaction on top of it. So yeah, what is vision language model? Easiest way is vision plus language model. That is, you can perform tasks on images now, and you can do next token prediction, VQA, etc. So if you give this image, this cat is, the language model should predict the word grumpy. Now, the architecture. So architecture, you can perform VQA, answering questions from images, document understanding for data visuals. ColPali also have special tokens of localization and segmentation, so you can also perform localization and, VLM also have these tokens. VLM that I'm talking about is Pali Gemma, and there's a very good blog by Hugging Face. You can perform zero-shot visual Q&A, one-shot learning, etc. with instruction. So what basically happens is now the text tokens, embeddings, and the image embeddings like kind of coexist in one latent space. So how it happens? It happens with Pali Gemma for this example. So LLM can only take input as text prompts, tokens of text prompts. So how do we feed in the image, right? Because now we are dealing with image as well. We have to do VQA on image. We have to do all this task on images. So what do? We need a visual encoder, right? The visual encoder then extracts features. One sec. There are feature vectors, and then those are given to a projection layer, which again generates a token. So what happens basically here is the projection layer is able to bring both the text and your image in the same latent space. Image tokens and text tokens exist into same latent space. So there's again a very good blog post by Google because it was developed by DeepMind. Okay. Okay, so before getting into late interaction, I just want to touch on multi-vector retrieval because it's kind of an important point. What happens in multi-vector retrieval is you remove the pooling layer. So basically what used to happen in text sentence transformer, that they used to have these tokens and they have pooling layer in between, and that created embedding that is like a CLS token or EOS, special tokens. But here, all the tokens participate and all the tokens generate embeddings, right? So now we enter late interaction model. I told you, like in late interaction model, we remove the pooling layer and we generate embeddings for each tokens. So you might be wondering, what is interaction? So interaction refers to the process of evaluating relevance between a query and a document by comparing their representation. When the comparison is happening, when the similarity is being calculated, that part is the interaction. So what is late? Late is when the encoding is happening, right? So is encoding happening after this interaction, before this interaction? So in this case, the tokens interact and then the encodings are. The first encodings are made and then interactions happens. Okay, so there's a whole mathematical thing here where query token and embedding document token embedding similarities is calculated, maximized over number of document tokens, and summed over query tokens. What that means is basically I'm showing you this block architecture. What it means that each query token and each document token will be similarity will be calculated, and the maximum similarity will be taken out and summed over. So this is what gives you the score. Each token, query token and each document token, similarity is calculated, maximum is selected, and then scored over. All the maximums are like summed over, right? Okay, so after so many things, you might be like, what will happen to memory? So your memory will crash on Colab or your local, GPU, CPU, and that's like really sad. So enters quantization. So how many of you have heard of quantization? Good. How many of you have actually deployed RAG in production and faced issues with chunking? All right. Okay. So quantization basically is taking higher granularity to lower. That means if the precision is very large, we are trying to reduce that. So what is happening? First of all, there's a really good blog post by Martin Grutenstorff. Okay, so this is what is happening. Let's assume there is a 7 billion parameter model, and we have given a 64-bit. That will occupy like 560 GB. Or 32 bits if we give, then it will occupy 280 GBs. So you see there's a massive reduction in memory. It not only kind of quantize weights, but also should be activation. So what we are doing is reducing the bits of the mantissa, because that will kind of reduce precision. So if you have 3 point something 10 digits after 3 point, it will be reduced like 3 point to 5 digits. Okay. So now you have your weights quantized. Now you have smaller weights and activation. How do you inference them? So one of the way is ONX inference. There are other ways like GGUF and etc. They also work, but one of the ways in ONX and efficient runtimes for graph processing. So what ONX was a framework for taking one ML model to another framework. Like it used to be like representation, but lately it has been used to make models more portable and for hardware optimization, right? Okay, so how do you inference it? So one of the way is embed anything, the library that I'm developing, that is inference, ingestion, and indexing in Rust. And we have crossed over 250 plus downloads, 250K plus downloads, and 600 plus stars. And we have both Candle and ONX, so you do not need like a special model, ONX model. You can actually take HFLink and then try it out. Try the models. People use it for different ways, for experimentation, etc. Okay, so performance of embed anything, how much Rust is offering. So yeah, we are faster than the library called FastEmbed, sentence transformer, but this only measures model inference speed on ONX. It has been repeated hundreds of times to simulate thousands of documents, and these are available on our GitHub benchmarks. Okay, so a little bit on results. So if you use ColPali, you will, and query it with large number of documents, you will get the page numbers and the file name and page numbers. And it takes about 23 seconds without model upload and 34 seconds with model upload. Okay, so ColPali seems like the solution for everything, but its primary limitation is it has been designed for PDF type documents, and the support for multi-vector is quite narrow right now. Yeah, I wish I could have shown you the demo, but there's, guess, no time. Okay, a bit of acknowledgement to Akshay for quantization in Optimum and manual phase for ColPali. And the final takeaways. Okay, so these are certain new things that we are working on, creating awesome demos for embed anything on browser, add support for ingestion for different remote and vector quantization. You can use embed anything to make your current Python indexing project faster and efficient. We support ColPali, Colbert, all different kind of models. Yeah, so let's stay connected. This is Repo, this is me on LinkedIn, and we are also building a community. If you face any kind of issues with embedding models, you can just write to us, and we are also developing a local application for your local RAGs and local AI. Thank you.
Thank you, Sonam, for this super fast sprint talk on ColPali. Do we have any questions? We still have 3 minutes left. Yes, I see one.
Hello, thank you for the talk. One question I have, in the beginning you were talking about chunking and context and that you don't have to do that when you're using techniques like ColPali. But what is when your context spans across multiple pages?
Yeah. So the input for ColPali is the image of the document, and the output is the file name and the page. So the whole page comes in the context. So it won't be like this small chunk will be the output. The output will be the whole page.
But what if you have a header that is important for context on the one page and that spans across 2 pages or 3 pages?
Yeah, so the maximum similarity will be given first. Like it gives you n number of pages. So if I go back in my presentation, if you see the output, so there are n number of pages retrieved. So it based on similarity, which is above and which is down below. Yeah. Thank you.
Do we have one more question for the last minute?
Yeah.
Yes.
Yeah. Thanks for the presentation. I have a question around, there is a general problem with using VLMs or ColPali because of the late interaction. They tend to be slower. So did you experience any of it, and how did you try to solve it? Thank you.
Yeah, it's a little bit slower than other models because it's pretty heavy and it is pretty task intensive as well. But just as I told you, like the problems are bigger than the speed right now. Like all those extraction and chunking is pretty tough. Yeah.
All right. Thanks for your questions. Thanks for your talk.
Thank you.